Hello everyone, welcome back again to my channel. In the last video, we discussed analysis of variance and we proceeded to the post hoc to do the deep analysis in the ANOVA. In today's video, we are going to discuss correlation analysis, that is to determine the relationship among items. So this video will cover what you need to know about correlation, how to report, and then later we go into the SPSS, we run the correlation analysis, and then we report, and then we move on to present it in APA style in Word, such that your supervisor will appreciate it. So now our next thing to do is, what is correlation or correlation analysis? We said correlation is a statistical technique used to measure the strength and direction of a linear relationship between two continuous variables. So when we say two continuous variables, it should just be the responses to the variables should just be numbers. So for example, we have age and height. So age is measured in the form of a number and the height is measured in the form of a number. So this one, income, and then consumption. So how much you earn, how much you spend. So these ones are all perfect for correlation. So it measures the strengths of the relationship. So when we say the strength, is that relationship very strong or it is weak? That is what the strength is. And the direction is, is the relationship moving together or it doesn't? For example, when we say direction, maybe demand and supply. So demand, when we are taking demand with price, when the price of an item is low, the demand of it becomes high. That means it has inverse relationship. So the direction is inverse. When the price is increasing, the demand for it is also decreasing. But supply, when the price is high, the higher the price, the more the people supply the items. So the direction is direct. So we measure the strength and direction of the relationship. And the relationship, how are they related? So what you have to take notice is the strength and then the direction of the relationship between two continuous variables. And then the coefficient is called Pearson's coefficient and is denoted by R. So we also have other coefficients like Spearman's, Kendall's. So we will talk about them later. And then the range of this R should fall between -1 and then 1. When it is negative side or when the result is negative, it's just telling us inverse relationship. When the result is positive, it is direct or positive relationship. So if R is equal to 1, it implies perfect. So when it is 1 or -1, that means we have perfect relationship. But when it is negative, perfect inverse relationship. When it is this one, positive 1, it is perfect direct or positive relationship. So that is how it means. And when the value is closer to 1, that is to say 0.6 to 0.99, it implies strong positive relationship. So once it is positive, you use strong positive relationship. And then when it is within this range, this one is closer to 0.5, that is to say 0.4 to 0.59. It means it's moderate positive relationship. And then when it is closer to 0, that means, and it is positive, it means it is weak positive relationship, that is within this range. So, and then it applies to the negative side. So when it is closer to -1, that is within this range, -0.6 to -0.99, it is strong negative relationship. And when R is within the range of -0.4, closer to -0.5, like within this range, it means moderate negative correlation or relationship. And when it is closer to 0 and it is negative, it is weak negative relationship. And when R is 0, that means there is no relationship at all. So now let's see some assumptions. The variables must be continuous. So that means it should either be interval or ratio. So when we say interval, that means there should be meaningful differences within the variables, within the categories. For example, maybe I am 20 years, someone is 18 years. It is clear that I am 2 years older than the person. So the difference is 2, and that difference is very sensible. That means I was born 2 years before he was born. And then ratio, it has a meaningful 0 starting point. For example, when we talk about someone's age, if the person is born today and then we ask what is his age and you say 0, it doesn't make sense, because once the person is existing, the person had some age, maybe at least in months or weeks or some hours. So that one, if you say 0, it doesn't make sense. But for example, if I ask, how many people die in your house today? If no one dies and you say 0, that 0 makes sense. And then this side, the relationship must be linear. So that is to say that we don't have to have y is related to x squared. No, that one is quadratic. So y should be nearly linear related to x. No extreme values. So the values should be clustered within the mean, like they should be closer to each other. Some shouldn't be appearing extreme in the data set. And that is to say the data should be approximately normally distributed. So approximately normally distributed. And we have done normal distribution. Please, if you haven't watched my normal distribution video, it is in the you can watch it within my videos. And then there should be homoscedasticity. They should assume equal variances among the variables. So these are the assumptions. And what will happen if you did not check these assumptions? It will lead to misleading results. That means your p-value is likely not to be accurate. Your p-value can give you significance when at the normal circumstance it is not significant. Your correlation can give you strong positive or strong negative when at the normal circumstance maybe it is weak. So these assumptions are very important. Failure to do them, it can lead to misleading results. And when you run the analysis in SPSS, your output comes in 3 formats. We have the R, which is the Pearson's correlation, which shows the relationship between the variables, the relationship and strength of the relationship among the variables. The p-value, which is also the significant value, tells whether the relationship here is significant or not. And then n tells us the sample size, or indicates the sample size. So when we run in each variable, we are going to see these 3 outputs in SPSS. But we have to know how to summarize it in a way that it will be very presentable. And then when the data is, this one you have to take note, when the data is normally distributed, we use Pearson's correlation coefficient. If it is not normally distributed, we use Spearman's rank correlation. So this is what you need to know about correlation. Now let's pick our data set and see how we can practice, if we can practice the correlation. So this data set I have here is restaurant data. So for practice sake, so we have location of the restaurant, service quality, and some other things. I will leave the data set in the description section so that you can download and practice. So we have 11 variables. This one is just for practice purpose. So now to do it, I want to find out whether there exists a relationship between location, service quality, food quality, and then customer satisfaction and online rating of the food. So we want to check if there exists some relationship among them. And to do it, we go to analyze. And then we go to correlate by variates. You choose by variates. So at the normal circumstance, this is how it should be. So you will select the variables you are interested in. So we have location, food quality, service quality, and then we have customer satisfaction, and then online rating. We have them here. Correlation coefficients, I have already checked this one, the normality, and they are all normally distributed. So make sure you check the Pearson's. If it is not checked, check it. And then you come here and then make sure the two-tailed test is being checked. And that is all you need from here. So you say okay. And then this is our results. Like I explained, the expected output. When you come to the location, you could see Pearson's correlation, that is our R. And then we have our significant two-tailed, and that is the same as our p-value. And then we also have our m. These are the three things, and then each and every one of them has its own values. So in my next video, I am going to explain these ones and then show you how we report the findings in your thesis. So please don't forget to watch the next video.